Okay, so this video is going to be on sections 4.2 and 4.3b, and the objective is I can determine whether a relation is a function and find the domain and range of a relation or a function. So a relation is just any set of ordered pairs, x, y, and the domain is the list of the x values, and we always list them in order from least to greatest, and the range is a list of the y values, and they're in order from least to greatest. So over here it tells you domain, x values, input values all mean the same thing, and then same thing over here, range, y values, output values all mean the same thing. So here's an example of a relation, and I have it as a set of ordered pairs right here, and then here we have the domain and range underneath it. Right here is the domain and the range. So the domain is the x values, but they're in order from least to greatest. So -1, 0, 2, 3. And the range is the y values, but in order from least to greatest. Then I also have them in a map, which is what we call this over here. We have the x values over here in order, and we have arrows going to whatever y value they match up with over here. And the y values are also in order from least to greatest. And then we have them in a table. In the table, the x values are in order from least to greatest, but then the y value that matches with them in the ordered pairs is across from them. And then you guys know how to graph ordered pairs. Okay, so we're going to take this relation right here from the ordered pairs and put it into, find the domain and range, put it into map, a table, and a graph. So the domain, we always do the curly brackets. That one didn't turn out very well. And then we go in order from least to greatest. We only list each value once. So the lowest one is -5. We're only going to list it once. And then after that, we have a -2 and a +1. That brace is no better. And then for the range, we do the same thing. We do the curly brace. That one's a little better. When we list them in order from least to greatest, so we do -2 and then 3, and that's all we need to list because there's repeats. Then when we put it in a map, we do the same thing. So we do -5, -2, and 1, and the domain will be over here. And the range will be over here, so it'll be -2 and 3, -2 and +3. Then we'll do arrows. So -5 goes with the 3, -2 goes with the -2, -5 also goes with the -2, and 1 goes with the 3. Then we'll put it in a table. So I'll put -5, -5, -2, and 1. So I put the x values in order, and I'm going to put the y values that match up with them. So there's a 3 that goes with the -5, there's a -2 that goes with a -5, -2 goes with the -2, and 3 goes with the 1. I got those all from the ordered pairs. And then we will graph this. So I'm going to graph -5, +3, which it's going to be hard to get it on the right spot. That's pretty good. -5, -2, -2, -2, and 1, 3. Okay, so functions are a special kind of relation where every value in the domain, relates to exactly one value in the range. So another way of saying that is every x value has exactly one y value, or every input has exactly one output. And one way you can tell this from a graph is if you can draw a vertical line through the graph and it only hits the graph in one spot, then it's a function. If it hits in more than one spot, then it's not a function. Okay, so let's look at what functions look like as a set of ordered pairs. So here we have a set of ordered pairs, and it is a function because every x only has one y. 0 only goes with -1, 1 only goes with -2, 3 only goes with -4, and 5 only goes with -6. This one's not a function because 0 goes with both 2 and 3. So the x value of 0 has 2 y values, so it's not a function. So does this one represent a function? -2 goes with 6, that would be yes, because every x, this is not turning out well. There we go. Every x has only one y value. Sorry, that writing is not very good. So here's what it would look like on a map. This one on the left is a function because every x value only has one y value. It doesn't matter that they all share the same y value. The one over here is not a function because the x value of a -1 has two different y values, and so it goes to the 3 and the 8, so it's not a function. Okay, let's look at all of these ones. So are these functions? The first one is not a function because the input of a 3 has 4 different outputs. That's not a function. I'm just going to put no. The next one, the middle one, is a function because each x value has only one y value. And number 3, or the last one, is also yes, because each x value only goes with one certain y value. Okay, here we have two tables. One on the left is a function because each x only has one y. One on the right is not a function because when x is 1, it goes with two different y values. It goes with the 3 and the 2. So this one says to fill in the table so that the table on the left is a function and the one is not a function. So basically for the one on the left, I can put any number here. I'm going to put a 3. Any number that's not already used in the domain, and then does not matter what the y value is. And then to make this one not a function, I'm going to reuse any value from the domain. I'm going to reuse the -1, and I'm going to make it also go to 7. So since -1 goes to 2 and 7, it's not a function. Okay, so these graphs on the left are all functions because they pass the vertical line test. No matter where I draw a vertical line, it only goes through the graph once. Or that's another way of saying each x only has one y. But the ones on the right are not functions because if there's even one spot where I draw a vertical line and it hits the graph more than once, then it's not going to be a function. So on the left, we're going to draw two graphs that are functions. And on the right, we're going to draw two graphs that are not functions. So there's a function, there's a function, because anywhere I draw a vertical line, it'll only hit the graph once, or every x only has one y. And then on the right, we'll do two graphs that are not functions. This would not be a function. This would not be a function. Those are just two examples.